This video will be a recap of what we have discussed about chemical nomenclature in class so far. And let's begin by saying that this table that you see here is all the polyatomic ions that you need to memorize for the exam. Unfortunately, there is nothing to explain here. Well, not that much to explain here. You mostly are going to rely on memorization to succeed in this part of the class, because we have to see this as you being able to know the names of these polyatomic ions and know the chemical formula of those polyatomic ions. And as important as the formula, it is what the charge is. So you need to know all those three things for each one of these polyatomic ions. Okay? And you need to know that because questions from the exam would be of those types. Can you tell the name? If I give you the structure, can you give me the name of the polyatomic ion? If I give you the name of the polyatomic ion, can you give me the structure? If I give you the name, it's going to be the name in this case. Can you tell me what the charge of that polyatomic ion is? So this is the type of questions that you will be seeing here. Okay, there are a mistake here. This ion here, you usually can find it as bicarbonate, but that charge is -1. Okay, and also this hydrogen sulfide you can also find as a bisulfide, and the hydrogen sulfate you can also name it bisulfate. Okay, you just replace the hydrogen at the beginning by. You do that for these three ions. You don't really do it for this, for hydrogen phosphate or dihydrogen phosphate. So that being said, questions in the exam. Can you tell me what information we are asking for here? Okay, so this is one ion that you need to name. It's SO3 2-, and when in doubt, just remember you have SO3, you have SO4. They have two different names. They have sulfur in them, but the SO3 is ITE and the SO4 is ATA. So that SO3 2- is sulfide. This contains nitrogen, and nitrogen can form these two. The lowest number of oxygens is ITE. The largest number of oxygens is ATE. So this one here is nitrite. Okay, luego we have phosphate. PO4 is just the PO4 phosphorus and oxygen. That's a 3-. So here you need to answer. If we are asking for the charge, it's either a 3-. You can also say -3, and it should be just fine. And the ammonia, that is basically the only polyatomic cation that you need to know. So it's positive, and is a +1 or 1+. Okay, you need, in this case, it's just 1. Usually you omit the 1 in everything that you do, but in this case you have to indicate the 1. So it has to be +1, the number, or 1+. Okay, so this is the only way to do this is by memorizing all those polyatomic ions. So we can also ask you what is the name of Na2SO4. This is sodium, and you need to recognize this as sulfate, and that's basically what you do. So you have sodium sulfate, so A is out of the question. The other three are sulfates, right? However, you have to remember that sodium is constant charge, and the charge is +1. So don't get confused with this one here. You just use that one Roman numeral only if it's a variable charge. So sodium is a constant charge, so those two are not possible. So your name is just sodium sulfate. what is the chemical formula of sulfur hexafluoride? So you have sulfur, there is nothing, no prefix there. If there is no prefix there on the first one, there is only one sulfur. Okay, when it's the first element in that formula, you can omit the mono, no need to indicate it. Just saying sulfur indicates there is only one sulfur there. Then you have hexa, which means 6. So if it's fluoride, it's fluorine that we have there, and we have 6 fluorines. So the formula is just SF6. That's a subscript there, but when you're answering this question, is SF and just your normal 6 there. Okay, these are element symbols. So whether they are lowercase or uppercase will matter, because you have to respect the nomenclature of the periodic table. So it has to be capital S, capital F, and a 6. In this is one case in which if you say SF6 is going to be a wrong answer. Another thing that you need to know is the common charges of the monatomic ions. So just looking at the periodic table, can you tell what the charge of that particular element is? So we have potassium, which is a group 1, has to be +1, and we have nitrogen, which is if you take a look at nitrogen here, so we have neon, we have fluorine, we have oxygen, and then here comes nitrogen. So nitrogen is 1, 2, and 3 spaces away from the noble gas. So nitrogen, the normal charge is 3-. So we have potassium with +1, and we have nitrogen with 3-. If you switch the charges here, then you end up with this 3 comes with potassium, this 1 comes with nitrogen, K3N. Okay, that would be the formula for potassium nitride. Can you name this compound? We have Cl2O. So you have chlorine, and you have 2 of them, and you have oxygen, and then you only have 1 of them. So the 2 goes with di, and the 1 goes with mono. You omit if it's the first element, but oxygen is not the first element, so you need to have the monoxide there. So this has to be monoxide. And if you can identify that, well, your answer is already there, because you know this is oxide, this is oxide, and this is oxide. If you have to use the monoxide, then those 3 are not possible. And this is an ion. Chloride is an ion. This is a molecular compound, not a polyatomic ion. Therefore, answer E is also not possible. So you have dichlorine monoxide, which is basically conveys all the information that you need here. What is the correct chemical formula for titanium 2 sulfate? We already know sulfate is 2-. You have to memorize that. And titanium 2, symbol of titanium is Ti, and the 2 indicates that that's the charge of this element here, so it has to be a 2+. So if you switch the charges here, it's going to be Ti2SO4 2, but you can omit those, because after all 2+ and 2- cancel each other, so you can just put them together, TiSO4, and that would be the formula for titanium 2 sulfate. Once again, the only way for you to get this right is to memorize what the structure of sulfate is, for example. And then titanium dioxide, well, you memorize the name of titanium, you can locate it in the periodic table for the symbol, and the 2 is indicating what the charge is. So how about we use this to work some other examples? Okay, let's say we want to know what the name for NaClO is. Okay. Can we identify this as a covalent or ionic compound? Well, you see a metal here, and then you have non-metals, so this is an ionic compound, not a covalent compound, so we can actually forget about all that side of this diagram. Now we have a monatomic cation. That's sodium, right? That's a yes. Is this a constant charge metal? Well, it's sodium, is group 1, so the answer is yes. So we name the element, right? That's sodium. Now we work with our ion. Is that a monatomic ion? Well, no, it's not a monatomic ion, so you forget about that side. Is that an oxygen ion? Well, actually, yes, it is. Okay, it contains oxygen. So if you don't remember the name of that particular one, at least you have to remember that chlorine can form Cl, ClO2, ClO3, and ClO4. All of those have one negative charge. Where does this falls into this? Is that the one with the least or the most oxygens? Well, it's the one with the least. So you have to add hypo, that comes from chlorine, and you end up with ITE. So this is sodium hypochlorite, and that's the main ingredient in common household bleach. What is the correct name? Let's say we have here FeF3. Once again, is this an ionic or a covalent compound? And then you have a metal there with iron, so it's ionic. We can forget about the rest of the diagram. So is that a monatomic ion? Yes, it's just iron. Is it a constant charge ion? Well, no, it's iron. Iron is a variable charge ion. So we use a Roman numeral for the cation charge. Here we have to remember that fluorine has a minus, therefore iron will have a 3+, and then we name the cation first. Iron.
Wow, I wasn't expecting to see you.
3.
Huh? Okay.
So once we have that done, then we move into the an ion. Is this a monatomic ion? Well, actually, yes, it is a monatomic ion. We forget about this side of the diagram now, and then we change that to IDE. So this is fluoride. Okay. Now, how about we name something else here? How about we name HNO2? In this case, can we identify this as an ionic compound? Well, there is not possible to do that because there is no metal here, so it's not ionic. It's a covalent compound, so we can forget about being ionic. Is it named as an acid? Well, you have hydrogen here, so that suggests we can forget about this side, and we can forget about the rest of the diagram. Is this a binary acid? Well, no, it's not. It's an oxyacid, and then we have here it can be HNO2 or HNO3. That's the only possibilities for nitrogen acids. Therefore, we just focus on these two. So it is the one with the less oxygen, so that's nitrous. And because it's an acid, then you just add the termination acid. So the name of this is nitrous acid. Now the correct name for, let's say, P4S6. Okay, so is this an ionic or a covalent compound? Well, it's not ionic. There are only non-metals here. So is this an acid? No, it's not an acid because you don't have hydrogen there. so we can forget about the rest of the diagram there. Now we name the first element. The first element is phosphorus. And how many you have here? There you have 4, so that's tetra. We move into the second element, and that's sulfur. And let's stop there for a moment. We give the prefix, which is 6 atoms you have there, so this is hexa. And then because that's the second element in that formula, then you have to change the termination to IDE, so this is tetraphosphorus hexasulfide. So this is how we work chemical nomenclature. This diagram is for you to help, I would say this will help you memorize those polyatomic ions. I would recommend you work this diagram with the list of polyatomic ions by your side, and then work as many formulas as you can. By the, I don't know, you can have 20, 30, 50 formulas, and by the time you are done with those 50, you will have memorized all those polyatomic ions. Okay, that's the end of this video.